Hello everybody, today we're going to look at how do we solve quadratics using the square root. So we've seen solving by factoring. If you had something like x squared minus 4 equals 0, this is a difference of two squares. It would be x plus 2 times x minus 2 equals 0. So x equals negative 2 or positive 2. And what I'm going to show you today is a different way of solving this. Now before we move on, I'd like to point out that you can only solve using square roots if you only have an x squared term. You can't have both an x and an x squared. So like the problem that we just saw, x squared minus 4, we can solve this using square roots because there's just an x squared. Alright, so let's look at how we would do that. We take x squared minus 4 equals 0, and we would isolate the x squared term. Okay, so that just means get it on one side by itself, so x squared equals 4. And now since we're solving using the square root, we're going to take the square root of both sides. All right, now anytime that you take a square root, you must use this symbol right here, which is plus or minus. All right, so the square root of x squared is x, and then we would say equals plus or minus the square root of 4, which is 2. Now why do we have to use plus or minus? Well, let's think about it. So let me box in my answer here. If I were to plug these answers back in, 2 squared minus 4 equals 0. Is this true? Yeah, 2 squared is 4, minus 4 equals 0. But what about negative 2 squared minus 4? Isn't negative 2 squared just the same thing as 4? So we don't know if this x was a positive 2 or a negative 2. You can also just think about this, since it's a quadratic that's been shifted down 4, like just graphically, right? It has two x-intercepts at positive 2 and negative 2. All right, so let's try an example where maybe the answer isn't as easy as plus and minus 2. We're going to go through the same steps as just solving an equation. It's just instead of an x term, we have an x squared. So I'm going to subtract 5 from each side to get 3x squared equals 36. Okay, trying to isolate that x squared term, I divide each side by 3. So x squared equals 12. Now that I've got just an x squared term, I can take the square root of each side. So I have x equals plus or minus the square root of 12. All right, now I have to think, can I simplify this radical? Do any perfect squares go into 12? So over here in my little thought bubble, I'm thinking, all right, 12 is the same thing as 4 times 3, and 4 is a perfect square. So I'm going to pull its square root out. X equals plus or minus, the square root of 4 is 2, so it comes on the outside, and you have that 3 left over. So the two solutions to this equation were x equals plus or minus 2 times the square root of 3. All right, so here you have a chance to try this on your own. 6x squared equals 150. Try to find x, and then if the radical needs to be reduced, go ahead and reduce. But for now, pause the video and try it on your own. All right, so you just divide by 6, x squared equals 25. 25 is a perfect square, so whenever we take the square root, x equals plus or minus 5. All right, this example is a little bit different because, as you can see, it's not just the x that's squared, it's the x minus 6 that has been squared. So my first step is going to be isolate the squared term. So that means I'm going to isolate this whole term right here. All right, so to do that, right now there's a 1/4 on the outside. How do we get rid of 1/4? Well, dividing by a fourth is the same thing as multiplying each side by 4. See, because 4 and a fourth, they cancel each other. And I have x minus 6 squared equals 32. All right, now that I've got the squared term by itself, I'm going to take the square root of this entire term. Okay, so now the square root of x minus 6 squared, that really just knocks that squared off. X minus 6 is equal to plus or minus the square root of 32. Now I'm going to get my x by itself. Okay, to do that, I'm going to go ahead and add 6 to both sides. And we'll say x equals 6 plus or minus the square root of 32. And I only write the 6 in front of the square root because you typically put like your whole numbers in front of your plus or minus square roots. Okay, so I'm not quite done. The last step is I need to see if I can break down the square root of 32. So let's go back to our little thought bubble. Are there any perfect squares that go into 32? Well, yeah, there are a couple, right? 4 is a perfect square, 4 times 8. But a bigger perfect square is 16 times 2, right? So I can take the square root of 16 and pull it out. So I have x equals 6 plus or minus, the square root of 16 is 4. And then inside the square root left over is the 2 that the 16 was multiplied by. So here we have x equals 6 plus or minus 4 square roots of 2. And that's how we solve using the square root. Goodbye.